We are going to start our problem with a semicircle. Then we will pull the chord of this semicircle, which is also the diameter of another full circle. This circle will divide the diameter of our semicircle into three segments with the length of 3, 3, and 2, as you can see on the sketch. The question is, can we somehow calculate the area of this full circle? This problem was presented to me by one of my subscribers, Andriana from Ukraine. So thank you, Andriana, for this wonderful suggestion. And of course, as always, you guys can pause the video right now, try it out for yourself, and then come back and check the solution. Alright, so let's solve this problem. First, let's label the intersection points between our full circle and the diameter of our semicircle as A and B. Then let's label the intersection points between the arcs of those two circles as C and D. And finally, let's label the center of the semicircle as O and the center of the full circle as Q. Now let's say that the radius of our full circle is small r. Then let's pull the line which connects both of their centers. And let's say that this line has the length of x. Now let's notice the line CD, which is the chord of our semicircle, and the line OQ that connects the center of our semicircle with the midpoint of the line CD. We can use the special circular property which states that the perpendicular to a chord drawn from the center of a circle bisects the chord. As you can see, this is exactly our case. Since the line OQ is bisecting the line CD, this means that the angle at the point Q must be the right angle. Now you can see that the diameter of our semicircle is equal to the sum of all individual segments, which is equal to 8. And we can label the far left point of our semicircle as E, and we can notice that the line EO represents the radius of our semicircle. Since the diameter is equal to 8, this means that the radius of our semicircle must be equal to 4. Now we can rotate this radius to the point C, and we will notice that the line OC will also have the length of 4. Then if you take a look at the line AO, you can see that we can calculate this line as the difference between the radius EO and the segment EA, which is in our case 4 minus 3, so this means that the segment AO must have the length of 1. Now let's pull the perpendicular to the diameter of our semicircle from the point Q. And let's label this intersection point with this diameter as P. We can say that this line QP has the length of y, and we can notice that the line AB is actually the chord of our full circle. Now we can use the same circular property as before, that the perpendicular to a chord drawn from the center bisects the chord. Since the line QP is perpendicular to the chord AB, this means that it will bisect the line AB. So the segments AP and PB will be equal, and their length will be half of the length AB, which is 3/2, so we can say that the length PB must be 1.5. Now let's notice the highlighted line AB. It consists out of segments AO, OP, and PB. So if we substitute the values from the sketch, you can see that we can calculate the segment OP as 3 minus 1 minus 1.5, which means that the segment OP has the length of 0.5. Now finally, let's take a look at the radius of our full circle, and let's rotate this radius to the point B. In this way, we know that the line QB will also have the length of small r. Alright, so now we have everything that we need. So we're going to start by noticing a different right angle triangles and the Pythagorean theorems. First, we will start with the right angle triangle CQO. we can use the Pythagorean theorem and say that the leg r squared plus the leg x squared is equal to the hypotenuse 4 squared, and 4 squared is of course equal to 16. Then let's notice another right angle triangle OPQ. And let's again use the Pythagorean theorem and say that the leg y squared plus the leg 0.5 squared is equal to the hypotenuse x squared. Now we know that 0.5 squared is equal to 0.25, so we can write this down. And finally, let's notice the right angle triangle PBQ and use the Pythagorean theorem, which states that the leg y squared plus the leg 1.5 squared is equal to the hypotenuse r squared. Since 1.5 squared is equal to 2.25, we will substitute this value, and in this way, we got 3 equations with 3 unknowns which we can solve. So, you can approach this in multiple ways, but I'm going to substitute the second equation, which equals to x squared, instead of the x squared in the first equation, and we will get the following. Now we will just subtract the 16 and 0.25, and we will get that is 15.75. Next, I will just rearrange and implement our third equation, and we will get this following system of equations, which we will just add together. If we do this, we will cancel out y squared and minus y squared, and we will get that 2r squared is equal to 18, which means that r squared is equal to 9. And now it's pretty easy to find the area of the circle, since the area is equal to pi r squared. So we can just substitute the value of r squared, and we will get that the area of our full circle is equal to 9 pi, and this is our solution. Well, I hope you guys enjoyed this interesting problem. If you did, do not hesitate to leave a like or subscribe to the channel. Of course, if you found another way to solve this problem, please write it down in the comment section below. And until next time, see you all and take care.